Okay, welcome back. We are looking at section 3.3, which is really a continuation of our discussion on graphing linear equations. Specifically, though, we're going to look more into intercepts, which is, again, something that we've really been talking about all along. Remember that an intercept is something that crosses either the x or the y axis. And so if you were to cross the x axis, just to get my graph up here, if you were to cross the x-axis right here, you would be at a point of A0, and this is what we call the x-intercept. If you were to cross here at the y-axis, this is 0b, b being any value, and what you would see is this is the y-intercept. I'm going to abbreviate there. So we're just simply going to jump into this with our first problem. First problem is 4x is equal to 3y minus 9. As you're looking at this particular problem, it says for the following equations, find the x and y intercepts and graph the equation. So I say graph, you say XY chart. Go math. Awesome. Make sure you keep practicing. I can't hear you on this side. Okay, so XY chart, beautiful. My x-intercept and my y-intercepts, I need to get in here. I said that backwards, by the way. I didn't actually write it the way it was said. This is your y-intercept. This is your x-intercept. Just to be very, very clear. Okay, if I plug 0 in for x, I have 4 times 0 is equal to 3y minus 9. 0 is equal to 3y minus 9. 9 equals 3y, or y equals 3. So there is my y-intercept. I would have 0, 3. So if I were to graph this particular equation, just to plot as I go, 0, 3 puts me right here. Beautiful. Now, the next equation, or sorry, the next solution that I need is for x. So I have 4x is equal to 3y, my y value is 0, minus 9. 4x is equal to a negative 9. X is equal to a negative 9/4. Ugh, fractions. Fractions are fun though. Fractions are friends, not food. Now, that being said, if you have x is equal to a negative 9/4 and you have a graph that has no scale, you have no problem. You just specify, hey, this is negative 9/4. Boom, there's my point, and I graph. Now, for everybody who's using graphing paper, or you're using pre-printed graphs, or you're trying to graph within a computer system, it might be a little bit different. Remember, in the computer system, like my math lab, when you graph, you might have to put some false point, something, and then you click on that point and you can edit the coordinate values individually. But if you're using graphing paper, you're doing this by hand, then what you would be looking at is, where is this value? So 4 goes into 9 twice, so that would be a negative 2 and 1/4, or a negative 2.25 if you're punching it into a calculator. So that tells you right there that I'm looking at a value between a negative 2 and a negative 3. And I'm only 1/4 of the way to the negative 3, so I'm a little bit closer to that negative 2 value. Again, that's for purposes of graphing by hand. But you have your intercepts, you have your graph, and that's all you need. Let's move on. All right, next problem. I gotta get some board space here. I'm gonna go ahead and erase this one as well, just to get me nice and clean up here. X plus 2y is equal to 5. All right, x plus 2y is equal to 5. Again, same directions, find the intercepts and graph. So let's get our xy chart. 0 for x, 0 for y, and let's find them out. So I have 0 plus 2y is equal to 5. 2y is equal to 5. Y is equal to 5 halves. Told you fractions are friends, not food. They would always come up. All right. Now, you have x for the next one. X plus 2y, which is 0, is equal to 5. Or x equals 5. 5 halves, for those of you punching it into a calculator, is 2.5. If you're looking at it in terms of a mixed number, you're looking at 2 and 1/2. But if you're typing it into a computer, again, click on the point, edit the coordinate, you can type in 5 halves and leave it at that. Graphing wise, I have 0, 5 halves, which puts me right smack between 2 and 3, and 5, 0, which puts me right here. And there is my plot. Good. Now we did something like this one before, so I just want to touch on it again. I have y equals -6. And if I were to put this into an xy chart, remember this is saying y is -6. Does not matter what your x values are, y is not changing. Y is -6. So, intercept values, I know I need a 0 for the x. I can't put in a 0 for y. Ask yourself why. Y is -6. So that being said, this is the only intercept. It is the y-intercept value for you. The other point that you have to have just to be able to graph could be anything because you know that y is -6. So I'm just going to put 1. That means at -6, right there, I have 0, -6, I have 1, -6, and there is my horizontal line. Pretty straightforward, but I do have to point out, whenever you're dealing with a horizontal or a vertical line, this is an example of a horizontal line, you will only cross the axis one time. When you're dealing with linear equations, such as these, where you're crossing the x and y axes, you will only cross each axis at most one time. Very, very important. Other types of equations besides linear equations might cross multiple times, but linear equations can only cross one time. They're basically lines is what you're looking at. Lines don't bend. Okay, so let's move to the next problem. What is behind door number 3? All right, I have 3x plus 5y is equal to 0. Now, again, same instructions. I'm looking for my intercept value, and I'm looking for the graph. So, intercept values, graphing, I know I need an xy chart, 0 for x, 0 for y. If I plug 0 in for x, I have 3 times 0 plus 5y is equal to 0. That means I have 5y is equal to 0, which means y equals 0. Huh. Interesting. I got 0, 0 for my first point. What happens if I plug 0 in for y? The same thing. If I plug 0 in for y, that's 5 times 0 is 0. 3x equals 0. Divide by 3, x is 0. So it's the same exact thing, meaning I only got 1 point. I need one more point to be able to plot. Which point do you want to use? I don't really care. Pick one. I'm going to say 1. Why not? Actually, you know what? I'm going to change it up. I'm not going to use 1. I'll tell you why in just a moment. I'm going to use 5. There's a reason behind my madness here. Let's say I have 3 times 5 plus 5y equals 0. This is 15 plus 5y equals 0. 5y will equal a negative 15, and y will equal a negative 3. The reason I chose 5, somewhat cheating here, is because I kind of thought ahead and said, if I were to look at these 2 different values, I have a 3 for my x, my a value, if you will. I have a 5 for my b value attached to my y. I know if I plug in 1, I'm going to get a fraction. So how did I choose 5? Well, yeah, you could try at random, but I wouldn't suggest that. What I'm actually looking at here is if I'm looking at these 2 different values, I knew by plugging in some value of x that I would divide by 5. So I chose 5 so that I could cancel out the fraction. Just a little method to the madness. It's not a necessity. You can be as insane as you'd like. It's okay. We don't judge too much in here in my crowded classroom of me. That's all. All right. Okay, so sorry, I'm deviating way too much here. All right, so I have my origin, my 0, 0. Notice that because this is the origin, it is both the x and y intercept. And then I have 5, negative 3. So 5, negative 3 puts me down here into quadrant 4. And there is my plot. So it's pretty straightforward. Now, on your notes, there's a little section at the very bottom for section 3.3, which has a few questions. And I just want to talk about those really quick in a quick discussion. It says, can the same point ever be both the x and the y-intercept on a graph? Right there, the origin. We just had that exact instance right here. So yes, you can have the same point as both x and y axis, or x and y intercept, I should say, because it crosses on both the x and y axis. Okay, second question. What is the maximum number of x-intercepts a line will have, excluding the line of y equals 0? Now, what this means is how many times will you cross the x-axis with a line? And we said this earlier. With a line, you can only cross one time on either axis. The only exception to this would be a horizontal or a vertical line. And that's because if you're at the axis, then technically you're at all points that would cross that particular axis. You are the axis. But that's not the case in any other situation. So you can only cross with a line at most one time on either axis. You don't have to, but you can. Second question, will a line always have at least one y-intercept? Sorry, that's the third question. The answer to that is no. What if you have a vertical line? That vertical line will not cross the y-axis. And the last question, what is the purpose of the arrowheads? No, we're not trying to stab people here with these. What we're looking at is these arrowheads on either end of a line are indicating that that line continues in that direction unto infinity, or negative infinity, depending on the direction. So that's all we're looking at. It's pretty straightforward. That is the end of section 3.3 for our purpose. I will be continuing into the next section in another lecture.